And recording.
Welcome everyone to the Ontology Summit 2024. The topic of the track today is LLMs, ontologies, and knowledge graphs. Today is the 13th of March, 2024. And we have Fabian Neuhaus, who is going to be speaking. And I believe, Ari, you're going to be our convener today. So I'll hand it over to you.
Yes, well, thank you. So this is our second session in this track on large language models and ontologies and structured knowledge. For those people who might not have participated in some of our prior sessions, we started kicking off some discussion of all the tracks, and we had some discussion of the various architectures that might be evolved between large language models and on things like ontologies. We followed that up with a session on foundations, and we had Gary Marcus and John Soa present on largely their views on what LLMs lack for AGI. Last week we had Hamid Yiglu, who presented on large language models for ontology learning, which essentially it's an empirical work and demonstrated that there's a challenge for large language models handling complex domains like medicine, where there are many conditions to consider when we consider causal relationships, which is something that Gary Marcus and John Soa had already pointed to as a challenge. You know, what does the entity of the large language model application understand about this rich concept, as opposed to a scattering of linguistic relationships. Today, I'm very happy to introduce our speaker, Fabian Neuhaus, who is well known to this community. Fabian is a senior researcher at the Faculty of Computer Science at the Otto von Guericke University in Magdeburg, Germany. His main research areas are ontology engineering and ontology languages. He contributed to many things, including the development of the basic formal ontology BFO, its relationship ontology, ISO common logic, and the OMG distributed ontology modeling and specification language. Fabian is vice president of our partner International Association for Ontology and its Applications, IAEOA, and currently he is working on neurosymbolic methods, which fits into our general topic for the summit, neurosymbolic methods for ontology extensions and methods for integrating ontological knowledge in machine learning. And as Ken said, his topic today is ontologies in the era of large language models. Let me turn it over to Fabian.
Thank you very much. Thank you very much to all of you for coming. And you're right, this is, I'm mostly working on the subject of neurosymbolic integration and, using ontologies combination with not neural networks, not necessarily large language models. But this is not what I'm going to talk about today. This might be the case that Till is going to talk about that subject more next week. I'm going to talk a bit about ontologies in the area of large language models, and that is motivated by the general hype on the subject. I mean, we are in general in an area of hype, or a time of hype of generative AI. Here's the well-known Gartner hype cycle, and as you can see, here at the peak, according to them. And of course, that also reflects on the ontology community. And I noticed that because I have to review papers on that subject. There are a lot of special events, like special issues of applied ontology or special tracks at events on that subject. So there's a lot of interest. And more importantly, or equally important, there's an interest on funding organizations. So I had the experience that we were talking about with the funding organization, and they basically decided not to fund a project because of the lead scientist was convinced that ontologies will be either replaced by large language models soon or within the next year or so, and or if not, then at least they will be automatically generated by large language models. So I wrote this paper, which this presentation is mostly based on, which was motivated by these questions. Are ontologies becoming obsolete? And are ontology engineers becoming obsolete? And if not, what are the limits of extracting knowledge from large language models for the purpose of building ontologies? And as I said, there are two papers this is based on. One is has the same title, and the other one is on ontology development as consensus creation, which I co-wrote with Jenna Hastings. Now, I think the first point can be resolved very quickly. Are ontologies becoming obsolete? Well, it depends. Arguably, if your main interest in ontologies is artificial general intelligence, then I see a point in this argument because so if you think about Psych, which is probably the longest lasting ontology development project that's out there, as far as I know. And originally, at least, it had the vision to create artificial general intelligence with the following method. We first create an ontology or a knowledge base that contains millions of everyday terms, concepts, facts, and rules that compromise common sense. Then, on top of that, we have a system that is able to communicate in natural language with its users, so able to learn from its users, and then in the next step, the idea is enable the system to perform its own experiments. That way, the system would be able to go beyond what it can learn from humans. Now, I don't know whether large language models will ever be able to help us to go to artificial general intelligence. I'm doubtful, but that doesn't really matter. The point is, I think we can observe that large language models provide some functionality which is similar to what step 2 in the vision by Psych was. So I think if I wanted to go in the area of research of artificial general intelligence at this time, I probably would not use the ontological approach of Psych, but maybe large in this sense, at least right now, large language models look more promising. So I can see that point why, in some cases, people would say, well, ontologies, who needs that? I don't agree necessarily with it, but I see at least the point. But then there are other use cases. Most ontologies are not built for the explicit purpose of creating artificial general intelligence. They have a more limited purpose, like integration of knowledge. Here's just as an example of many ontologies, CABI. CABI represents large amount of knowledge about chemical entities, and its main purpose is to provide unique identifiers for chemical entities, and they can be used by other knowledge resources, and that way you can interlink and connect chemical knowledge across various resources. And obviously, that use case requires unique identifiers which are somehow accessible and available to you when you build your own knowledge base. And large language models just don't do that. I mean, this is just a different use case. So the questions whether ontologies are replaced trivially not by that in this case, just because different use case. So the more interesting question is, are ontologies engineers becoming obsolete because of automatization? And that looks more promising, at least if you just look at it quickly. If you give a prompt to ChatGPT, for example, I did that here in this example, provide a classification of tools in the form of an ontology in our Manchester syntax. It spits out a file. I mean, it's not completely perfect. You have to, massage it a bit, but then it can be passed by Prodigy and you get an ontology. Well, an ontology file. And so you can see it here. This is what it shows you. And of course, as a picky ontologist, there are things which we would do differently. So tools are distinguished in crafting tools and diagnostic tools and educational tools and hand tools, information technology tools, kitchen tools, mechanical tools, and power tools. It's clear to see that there are different classification criteria at work. And if you look then in more details, an instance is a hammer of a hand tool. You would presume, normally you would expect that to be a subclass, and there are no annotations, there are no definitions, there are no axioms. So is it a good ontology? No, it's not a good ontology. But it's the result of about 30 seconds of work. So the quality could be improved with better prompts, and large language models would get better. So, it seems not unreasonable if, within 30 seconds you can generate a bad ontology. Maybe with more effort you can generate a good ontology. So will ontology development then be fully automated using large language models in the future? The answer is no. And in order to understand why, we should think about the fact that automating ontology development is not a new idea. This field of ontology learning has been studied at least since the mid-1990s. The reason why I write that is because that's how far I can remember it. Maybe there are earlier attempts. There is a survey article from 2018, which surveyed 140 papers. It comes with this nice architecture where you basically have different steps of term extraction, relation extraction, and then axiom extraction. And there are various different methods how to do that. And all of them are based on text corpora. So large amounts of text, which are the basis of extracting the ontology. And large language models provide new tools to implement these functionalities. So we can, instead of using other methods, we can do, let's say, term extraction with the help of large language models. And since I will say a lot of critical things, let me stress that I'm absolutely fine if people want to develop this as in support of ontology engineers. I actually have done research my own in this direction, so I'm not against the idea, of course, of automating things if they can can be automated. But the idea that we can fully automate ontology development is something which I will now have a critical view at. So let me first state with the obvious statement that after 30 years of research, there are no widely used ontologies of any quality, at least, that are automatically generated. And my hypothesis is that language models won't change that at all. And I will provide two arguments, which are the main focus of the remainder of this presentation. The first argument can be condensed to attempts to automate ontology development are based on a misunderstanding of what ontology engineers actually do. So let's go back to what is an ontology. I'm obviously, from a philosophical perspective, there are different answers. I'm just now following Quine here. We start with a theory about a domain, and then we go to a formalization. If you follow Quine, then predicate logic, first order predicate logic. And then you have existential quantifiers or quantifiers, and those quantifiers basically give you the kind of entities that must exist or that the variables must refer to in order to make the theory true. And these are your ontological commitments. And ontology is basically a collection of ontological commitments from that perspective. And of course, philosophers are more interested in general kinds of entities and their relations. But you could also apply that to cars and shares. Now, computer scientists basically move a step up. They don't, when they talk about ontologies, they don't really talk so much about the ontological commitments. They look at the logical forms, because the logical forms or collection of formulas, that is from their perspective of an ontology, it's a kind of document or a file in a logical language which we can use for knowledge representation. And if you look at definitions in the literature of what an ontology is, then for example, here the one by Studer, an ontology is a formal explicit specification of some shared conceptualization. The formal explicit specification is basically the document in some logical language. And I focus here on the shared because it will become important in a few slides. Shared means that not shared in the sense that you spam the world, right? That you just make it available to everybody. Shared means more in the sense of consensus. People agree on that conceptualization. And that is important because to solve interoperability issues, an ontology needs to be adopted widely. And if there's no consensus, people will be unlikely to adopt the ontology. If there's an ontology which widely disagrees with your opinions about a domain, you won't use it. So the consensus aspect here is important in order, at least for ontologies that are used to solve interoperability issues. And these are the ontologies that I will be interested in from now on. I mean, of course, you can have your private ontologies. You can develop an ontology for your own that you don't want to share with anybody. That's fine. But these are, I'd say, not the kinds of ontologies that I'm interested in within the framework of this talk. So what is an ontology? An ontology is this shared a representation of a shared conceptualization. And the view of the automatic ontology learning community seems to be, well, we don't have the theory, we don't have access to the theory directly, but the authors who have that theory write papers, and then we can use the tools to extract the ontology from these papers. And that's reflected by the quote that I wrote here, cited here. So this is from the same authors who did this nice overview article. Instead of handcrafting ontologies, research trend is now shifting towards automatic ontology learning. Whenever an author writes something in the form of a text, he's actually doing it by following a domain model in his mind. He knows the meaning behind various concepts of a particular domain, and then using that model, he transfers some of that domain information in text, both implicitly and explicitly. Ontology learning is a reverse process, as a domain ontology is reconstructed from input text. So this is the conception of what the ontology learning community has of what they want to do. And it is basically a misunderstanding of what ontology engineering is, because the first model we looked at, the on the left side, that was the answer, or part of the answer to what is an ontology. That is not the answer to that question, isn't the same question as how does ontology engineering work? And the major flaw in the assumption here is that it assumes that there is a pre-existing theory. Ontology engineering never, I mean, at least not in my experience, never encounters a situation where somebody gives you, perfectly worked out theory and all you need to do it, take it and then translate it in first order logic. I wish it was the case, then my job would be much easier, but that's not happening. There's also the false assumption that a domain ontology just is a set of formulas. I will come back to that as well. So, but a more realistic view of ontology engineering is given by this diagram, slightly more accurate. So what you have is actually many, many views, but if you start an ontology development process, and then as an ontology engineer, you often bring something yourself to the table, some philosophical ontological assumptions, often codified as a top-level ontology. You make a decision on what ontology language you use, which constrains what you can say, at least in the formal part of the ontology. And then you work with the domain experts in order to develop both logical axioms and this semiotic grounding of the symbols in your ontology. And the important thing is this: if you develop that, you create a consensus. You don't just take one view over everybody else, because then the other people who are involved will at some point just leave you. And it's an iterative process. It's also, you don't need to develop one unified view. You just have a partial consensus that is so as much, goes as far as the ontology goes. So not everybody needs to agree about everything. And then you represent that consensus with the help of logical axioms, and they are important, but in my opinion, at least as important are the annotations which are in the ontology, which documents what the intended meaning is of the terms that you include in the ontology. So the main job of an ontology engineer is to create consensus, and this is hard work. It's way harder than just taking something and writing it down in first-order logic. And because, well, first of all, if you work with people or domain experts, their difference of opinions are often implicit. So it requires work and expert knowledge sometimes to actually make the difference explicit before you can even start the discussion about creating a shared view. You need to identify what the differences really are. Then you create, with the help of the domain experts, a new partial theory, and this needs to be a process where everybody is involved, because only a participatory process leads to the commitment of people to actually use the ontology. If you don't change the minds, at least insofar as that people say, okay, I don't fully agree maybe with everything in the ontology, but it's good enough for my purposes, so I will use it. If you can't achieve that, people don't commit it, won't use it, so it won't be useful for interoperability issues. And that's only one level of consensus creation. That's mostly the ontologies we built are not only for the people who are developing the ontology, but there are way more people who are in the community who are supposed to use the ontology, or hopefully will be using the ontology, because then we can solve interoperability issues, and but aren't involved actively in the ontology development. So as part of this macro level consensus, by macro level I mean people who are not ontology developers, you need to do things like outreach to the community. You need to have a proper license. There are sort of other things like be open to feedback and requests. So all of that is part of organizing that as part of the ontology engineering process. If your goal is to create an ontology which is used by people and adopted by people. Now, so that brings me to the summary of the argument. Ontology development requires consensus creation. This is necessarily a social participatory process. If you just tell people, here's my ontology, it's perfect, use it, people won't. They just won't feel like changing their terminology just because some outsider tells them to. And because it's a participatory process, it can't be automated. At least not fully, because, well, participation is the opposite of full automation. And that whole argument is the case with or without large language models. So on large language models don't change that basic problem of ontology learning, or the goal of fully automating ontology development. The second argument. There is no ontology hidden in the weights of the large language model. So the idea, which I think people have in mind if they want to use large language models, is, well, we start out with many views, as we discussed, and then there are many papers, and all these text corpus goes in the large language model, and then the large language model does its magic. And as a result, you have a unified view in the large language model. Now, this will be then used by with the help of some prompts for automatically generating the domain ontology. Now, that's I think the idea, the problem here is that what a large language model actually does is basically learns two functions and embeds sequence of tokens in an n-dimensional space, and then it maps points in that n-dimensional space to some probability distribution for the next token. This architecture makes large language models very good at navigating ambiguities and different perspectives, because the right choice basically will be triggered by the context, by the previous tokens. This functionality does not require the large language model to resolve any ambiguities. It does not require the large language model to provide consistent logical output, and it does not require the large language model to make any persistent ontological commitments. And I have some examples to just illustrate these points. So here's a nice example for logical failings of ChatGPT. I asked it, is every natural number other than 2 either prime or odd? And ChatGPT's enthusiastic response is yes, that statement is correct. Every natural number is greater than 2 is either prime or odd. And then it actually gives a proof by cases. First case, odd numbers, every natural number is greater than 2 is either odd or even. That's correct, obviously. Since 2 is the only even prime number, all other primes are odd. Yes. And then the next step is if a number greater than 2 is not even, then it's one of the odd primes. And that's obviously nonsense, but it sounds good. It sounds like a good proof, and that's why ChatGPT creates the string of tokens. And the second, I will skip the next step, but it's basically it looks like a case by it's covering the second case, but it's not really covering the second case. It's just producing stuff. So the proof, although it looks quite, looks like a mathematical proof, is obviously nonsense. And that's not a failure of the ChatGPT or the underlying large language model. It's just a function of what it does. It generates the next token based on the previous context, and it does not have anything which would enable it to have something like logical consistency or do logical deduction. I have in the paper some other examples where it just produces also logical inconsistent results. I give it a small riddle which even children can answer, and the responses aren't just wrong, they are logically inconsistent with the premises of the puzzle. Anyway, so this is the logical problem, and then we have the lack of persistent ontological commitments. I have a simple ontological question. Is a cave not a physical object? A cave is not a physical object. This is part of a longer discourse with GPT. And it previously claimed that a cave is not a physical object, so I asked it basically to verify that. And then it says, a cave, like a desert, is not a physical object in the strict sense. A cave is a geological formation and it continues. So in summary, a cave is not a physical object. It's a geological feature or environment with physical properties shaped by natural processes. In the same session, if, few more questions in between, I asked, is the cave as a geological feature a kind of a physical object? Yes, a cave considered as a geological feature is a physical object. A cave is a tangible and material entity that occupies space and has mass. So the justifications that it gives, one positive, negative, and the other positive, are both quite reasonable. Sounds like good ontological arguments, one in the one direction, one in the opposite. And again, that's fine. That's not surprising. It's a statistical model, not or a stochastic model, and not. It doesn't make ontological commitments. It just produces text. So the summary here is large language models are stochastic model that predicts tokens. They are not trained to resolve ambiguities or provide logical consistent responses or make persistent ontological commitments. So the idea in this original picture that you kind of go from training to the large language model to, or via training to the large language model to a unified view, a view which unifies the original divergent point of view, is just not correct. There is no unified view. That's a stochastic model. And so when you then add prompts, you get an output which sounds like ontological arguments. And I mean, in this particular case, in the example, I didn't use an OWL format. I did a natural language text, but we could have done it in a formal language, but the result would not be, it wouldn't be an ontology, or you wouldn't be guaranteed to come up with a consistent ontology which is reflecting somehow a summary or a unification of the original views on the domain. So my conclusion is large language models will not replace ontologies. They're just different use cases. And large language models will not replace ontology engineers by fully automating ontology development, mainly because ontology development needs to be a participatory process where people can interact with people. And this requires, at least for now, it requires humans, probably will always require humans. And large language models do not learn an implicit ontology, which just can be, explored by using prompts. However, and I want to end after so much critical content with a positive note. I have no doubt, and just by reviewing papers that people write, I have no doubt that LLMs will enable the development of fantastic tools that will support ontology engineers, will make our life easier. So I'm all for using them for semi-automatic or supportive purposes, but I don't think that the whole idea that we will use it for automating ontology development, that will fly. Thank you.
Fabian?
Yeah.
Thank you very much, Fabian. I know there are a number of things in the chat. We do this several ways. We have people raise their hand who have questions and comments, and we also have things in the chat. I'd like to say one or two things first. One is that when you're talking about not replacing ontological engineers, I very much agree with the idea of consensus building. And would just point out that I've had a number of sessions as part of prior summits on the idea of semantic harmonization, which is very much in line with that. So it's a slightly different phrase used. I'd like to also exert my prerogative as the moderator here to call on Michael Gruninger, your fellow NIST representative from the past, who had a comment here before we get to other people who have their hands raised. So, Michael, if you could unmute and read your ideas, some of which you put in the chat.
Oh, I got my camera on here. Oops. Okay, yeah, thanks. That was a great presentation. I mean, I liked the paper. I read it earlier too. But just kind of look at the claim. You said that there is no ontology within large language models, which I agree with. But I think that that claim does seem to support the idea that ontologies can still play a role in some of these other tasks that would be kind of general AI, because we do want to have explanations, and we do want to have these explanations in using the similar world models that we have, right? And so that ontologies would still play a role there in terms of providing explanations, providing common and shared arguments. So I mean, I was curious, like you said, there was this funding agency that said, hey, ontologies are obsolete because large language models are doing it. But the claim that large language models don't have an ontology sort of seems to be inconsistent with that claim.
Well, I'm not agreeing with their claim that that basically ontologies are obsolete. So I hope that was clear. That was yeah, I mean, I mean, that's part of my till of my research on trying to combine these things and making making use of ontologies to improve what we can do with neural networks, and on the other hand, we are also using neural networks to extend existing ontologies. So it's basically in a supportive role. So I think they complement each other. So on the whole thing of general, and my point was, I can see why people look at, let's say, Psych and say, oh, if ontology was built for that purpose, now large language models do it, do some of the functionalities they were talking about, do that better. So, I can see that argument. I didn't want to basically dismiss them as, didn't want to dismiss what they're saying completely out of hand. I want to say, okay, there are some use cases where ontologies were proposed as a solution where we can see that at least some of the functionalities that were originally intended to be done by ontologies or with the help of ontologies are probably now better done with large language models.
But I'm not sure if that's the case though, because just even the two examples you showed, right? I mean that there are inconsistencies in arguments, and you can convince them to come up with a different answer that's also kind of self-contradictory. I mean, the benefit of having ontologies is that once you detect an inconsistency, that's a bug and you can fix it, right? With a large language model, there's no notion of a bug. It's just a different thing to say.
Sure, I'm not saying they're providing exactly the same thing. Obviously, the benefit is you can create large language models can provide information about arbitrary things, right? Well, and you can do that with in a relatively short time with relative limited resources compared to if you would try to handcraft an ontology which covers everything, right? So I'm not saying that they're providing the same functionality.
I'll let other people talk. Thanks very much, though, for the opportunity. Thanks, guys.
Well, several people have their hands up, but let me call on Alexandru, who had a comment in the chat on this idea of consensus and had a different idea about LLMs and consensus.
Yeah, I don't know if there's different ideas. I fully agree with Fabian. It's just to extend the viewpoint a bit more and talk about what is consensus, or is the ontology engineering process the perfect way of building consensus. So I work for DIN, and my work is mostly on generating ontologies from standards and ontologizing standards too. So combining the two words. So when you start from a point of consensus and you know exactly how to generate, so we have a lot of projects in the research landscape, etc., where we take a standard and we generate an ontology out of it. Now, when you know exactly how you want to generate that ontology, and what the ontological framework is, what your upper level ontology, mid-level domain ontology is, and how you do it, you can automate that to a certain degree, and you already have the consensus in the standard. Again, for ontologies, when you build it from scratch, I don't know if the ontology engineering process is actually the best practice in the world for generating consensus. So that's also something up to debate. My point of view is that LLMs can automate a lot of the work. They cannot generate consensus. I totally agree with that because that's a really complex process that requires a lot of interest groups and other things to make sure that it's something that can stand the test of time. But they can do a lot of work that ontology engineers do, as long as you tell it exactly what it should do and what it should base the decisions upon. Because the comparison that you had before is like, take scientific papers and generate an ontology out of it. Well, there is no consensus underlying in those papers. So of course, whatever it does and it generates, it's gonna be very vague and random. That's my viewpoint. I mean, I don't want to. I totally agree with what Fabian says with consensus there, and also if you use LLMs to generate an ontology from scratch, you don't get very good results. But if you tell it what to do, if you tell it where the consensus is, you might get good results.
So thank you for your comment. You are in a unique situation that you work for a standards organization and have the job of standardize. It seems like the job of formalizing standards. You're right. In this particular situation, you're an absolute luxury situation. If that's all you're doing, and you're not combining different standards, because then you again, have the problem again, right? Because often you have competing standards or overlapping standards which you need to integrate, and then again you have to create the consensus on new. But yes, in that situation, ontology engineering is super easy. You don't need an ontology engineer. You need a, since you're obviously in Germany, you need a Hiwi. That means a student who was trained to write OWL. And that's probably sufficient to just give them the, maybe I'm exaggerating a bit, but it's really going to be quick if somebody did the work already in consensus generation. So when I said that happens never, I probably misspoke. If all you're doing is taking one standard and assuming the standard is well documented, because not all are, and then you can do it. But that's really the exception. I've never been in that lucky in a situation where I was that lucky in more than 20 years.
Well, let me ask a follow-up question here, Fabian. You mentioned that prompt engineering may allow some improvement here. So what if the prompt engineering is to use the relations found in RO as part of the response? So you have essentially a standard, and you have BFO has essentially a standard. So you can direct it in that way. What do you think about that, or have you thought about that? Have you looked into that?
Well, I mean, how? So you're going to use all of the RO and as prompt, or
In the
use
prompt,
that
you say
in the yeah, but
yes.
how much of the ontology? I mean, you can't. Let's say you want to extend or you want to formalize some domain, and then you say as a prompt, here's all of RO. and here are let's say some additional information. Please create me an ontology. The prompt is going to be too long, so the large language model will likely not have enough tokens available to create that context it needs. Right? It will not basically use the whole of a whole ontology as an input. The other, I mean, the question is also, what do you mean by RO? Do you just mean the logical axioms, or do you mean the annotation? Because the logical axioms of most ontologies are not very helpful. The intended semantics is in the annotations. So, and often they aren't, I mean, sometimes they aren't very good either. So, yeah, I mean, I've never tried it, I have to admit, but I'm not positive that this will work. I think this is going to exceed the limits of tokens you can provide it if you have a large ontology as background.
Okay, maybe for a later discussion. Let me turn to Ravi now and then Todd, who have had their hand up for a long time.
Yes, Fabian, one question was, if ontologies are collections of commitments, then how do you deal with interdomain ontologies is one question.
So that you're referring to my slide where with Quine? That was, or that was basically the philosophical view where I'm talking about
It was more on the engineering aspects of ontology, where you are saying commitment, consensus and commitment are required before we can do ontology engineering in a way.
Okay, so let me just share my screen, I guess. This I'll be talking about this, right?
Yes.
Yeah, okay. So the ontological the point that I was trying to make here was that was illustrated with this example where we have a question: is a cave a physical object or not? I mean, you can reasonably argue in both ways, I think. I've never thought about the ontology of caves. There are many other examples. This is just one example which you come across when you ask ChatGPT some ontological questions. It's basically saying at some point, yeah, it's a physical object, and then the next point it says no. Well, rather, it starts with it's not a physical object, and then it says it's a physical object. So by what I meant here, it doesn't it makes a it isn't stable, right? The answer these are ontological answers that it gives, and it's actually this is in this particular case I asked direct questions, but it's also when you if you see how it uses terms like physical object or other like artifact. Another example was artifact, how it uses the term artifact in its responses without directly being asked about artifacts. Sometimes it uses it in one way and sometimes it uses another way. So the and if you want to extract an ontology, you want to have a consistent, view of the world, which you're interrogating, right? So the idea is that of this original, of this picture, what I think people think how it would work is that basically large language model will give you a unified view of the world where you have one set of ontological claims which are implicitly contained in the large language model, and then all you need to do is to extract it with the help of prompts. And my argument was there is no unified view. There are no persistent commitments about whether a cave is a physical object or not, because it's just not designed to do that. And thus, you won't get, if you ask this with similar prompts, you will get very different answers. And thus, this will be a problem to create a domain ontology.
And as you replied to Alexander, I see that there is a contention between this unified view and the way we do the prompts. I see that connection too. Thank you.
You're welcome.
Okay, so Todd has had his hand up, but I'd also like after Todd, Michael DeBellis has a follow-up to this question about what to use as a prompt or what to improve, how to improve and get maybe some consensus. So Todd first, and then maybe Michael if he can.
Hi, Fabian. Good to hear from
Hi,
you.
Todd.
I had a question, which is essentially the converse of your talk, and you briefly mentioned it in the response earlier. How can ontologies be used to improve large language models and, if you like, their responses? Have you considered that?
Yes, actually, Till and I published several papers about that in this direction. Our particular use case is with Cabby, because we worked a lot with Jana Hastings. One approach, I mean, it's a long story, but one approach is to, which we have used, is to train a large language model to predict extension of Cabby. So we give it a new chemical it hasn't seen before and say, okay, how would you put it in Cabby? Where would you classify it? And after it learned that, so the ontology would basically creating or extending the ontology becomes a new task, and that it becomes a pre-training task to do the thing which we really want to do, namely in this particular use case, predicting toxicity of chemicals. So we could show that if you take the normal or the standard approach, we used Electra in this particular case, but it also works with other architectures, then predicting toxicity of chemicals was very hard. If you use the ontology to create this ontological pre-training task, it enabled the system to basically absorb some of the ontological knowledge which is hidden in the hierarchy of the ontology, and thus then perform better on the other task, the poison prediction task. So that's one of several things we've done in order to, in this direction.
Were you able to measure the impact on the parameters of the large language model when you use the one or more ontologies in the pre-training?
We used one ontology in this particular case. We used Cabby, and what we measured was the F1 score of the results, right? So how well was it able to predict toxicity afterwards? And we could show that with the help of the ontology, it was able to perform that task better than without it.
Okay, thank you.
Okay,
You're welcome.
so Michael DeBellis, do you want to essentially tell us a little bit more about your idea about beyond prompt engineering for getting some consensus? I don't hear Michael.
Michael's still on mute.
Yeah, I can read his chat. The way to do it is not with prompt engineering, but with RAG, R-A-G, which I described above. I also built a BFO assistant that works quite well with a few BFO documents. And it
Okay.
has a link in the chat. So that's for some perhaps follow-up, but apparently Michael can't unmute or isn't unmuting. Anybody else want to raise the hand? I know that Dan Brinkley has made some comments.
I had a question for Fabian, and that has to do with stochasticity. If anything, which all things in real life are stochastic in nature, they don't follow exact mathematics, they do follow approximate statistics. But when you have such situation, what can you say about ontologies that you generate with it? I thought you kind of negated the argument by saying, but that is stochastic.
Well, I mean, my point was that it's difficult if your goal is to fully automate ontology development with the help of large language models. As I said in my previous answer, I think the idea here is that the large language model kind of implicitly generates an merged view of what it finds in the text corpora it's trained on, and that we can exploit. So I think the idea, and which I call a misleading picture of what is going on, would be that we then can use prompt to explore the joint, that merged view, the unified view, and then get a consistent ontology out of it. And my point was, well, that's not what the system learns. It learns a stochastic model, and for that reason, because it's a stochastic model, we can't assume, and there's no reason to believe that it will give a logical, consistent answer, that it will provide you with a unified view of the domain you're interested in. And I first made that case a priori. There's no reason to believe it. And then I gave two examples which showed that both logical reasoning and ontological consistency cannot be found, at least with the current version of ChatGPT. So that was the point. It wasn't. I didn't really wanted to say anything about the relationship between stochastic models and ontology. More that I want to point out that what the system learns, that there is no hidden ontology in the large language model. That was really my point.
Thank you. Thank you.
We perhaps have time for two more comments or questions. Alexandro has his hand up again, and then Matthew Lang, and I think that would probably do it for this session. So Alexandro, do you have your comment or question?
Yeah, I don't want to say too much. I just think that it's very interesting to note down what we think that an LLM can and cannot do, because then researching that and seeing into what level it can build an ontology or it cannot build an ontology is a great scientific fact or like research knowledge that we can take out of this discussion. That might be very interesting, because going to the bottom of it and seeing exactly how it works and to what level it does some things and it doesn't do them might be very interesting to research. That's it from me.
Okay, Matthew?
Yeah, can you hear me? Okay.
Yep.
Okay, great. Yeah, I'm just curious. You gave one prompt about the tool ontology, and you said, yeah, it's not very good. And then you gave a cave example, and you pointed out some inconsistencies. But I'm wondering if you've tried, chaining up a series of prompts where you're pointing out these logical inconsistencies, where you're actually drilling into the types of tools or what have you that you're building, using a tool like LangChain or something like that, so that you're actually using some of these different perspectives that the LLM has to gain consensus, if you will, within the varied perspectives that are coming from the LLM, right? Because you're getting two different perspectives on the cave, right? Essentially, right? And one of the things that an ontologist does is sort of harmonize these perspectives, or at least. And so I'm wondering, have you explored prompt engineering to try to harmonize perspectives?
So first of all, my point with my first point was, well, this was a 30-second attempt of creating a tool ontology, and I
Right.
think I made the point of saying, well, it's not very good, but it seems like if you can do it in 30 seconds, you can create a bad ontology, maybe with better prompts and better large language models. You actually will create a good ontology, right? So
Yep.
I wasn't so pessimistic about. I mean, that wasn't my argument. My argument wasn't just because it failed after my 30 seconds attempt. All is doomed, right? So no, I think you can obviously try to improve it with better prompts, and we explored it, and I'm just trying to find an example Till just sent to me very recently, which is funny, and I would like to share. We again, problem of not finding. Let me just share the desktop, and then here is which won't probably, since most of you are American, or the people who are American won't know, but it's a soccer example. So there's I think Till asked that. When did Germany win 5-1 against England in Munich? England, I mean, it's obviously soccer for in this context, and for people who don't know, both England and Germany are very strong soccer nations, and it's important to us. And unfortunately, Germany never won 5-1 against England, and in Munich, quite the reverse. England famously won 5-1 against Germany, and it's probably their biggest achievement since they've won the World Cup. At least they're quite proud of it. So the misleading question is, when did Germany win? And it says Germany defeated 5-1 England 5-1 in World Cup qualifier match on September 1, 2001 in Munich. The date is correct. The result is completely wrong. This match is often referred as a miracle of Munich by German fans. No, German fans would not consider this a miracle. German fans would consider it as a day to forget, maybe a middle-sized catastrophe. So then Till asked, when did England win 5-1 against Germany in Munich? And now it provides the right response. And this victory is famously known as the miracle of Munich by English fans, which is correct. And then, isn't there a contradiction? Yes, you're correct. And I apologize for the confusion. There was a mistake in my previous response. The correct information is that England defeated 5-1. It's correct.
Right.
And then, are you sure? And then I apologize for the confusion. My response was incorrect. So so it's easily misled. It's easily misled. So I'm not saying that doesn't prove anything again, right? So better prompts, fine. You can try to improve the situation.
And better language models, quite frankly, right? I mean,
also, yeah. I mean, that doesn't prove anything. It just says just first of all, I brought it up because I found this funny. The other thing is that it shows it's not that easy. But ultimately, my arguments were the underlying assumption that you have to make in order to believe that you can do this full automatization is that there is something that you can query with prompts, something which will not change continuously, and that there is this unified view. And I think the serious answer is there is no unified view. There's just a stochastic model, and the assumption that you can use better prompts. I don't see a reason why that would change anything. It will not change the fact that this is a mercurial stochastic model which will just give different responses each time depending on the prompts.
Thanks.
Well, we've gone a little bit over time. There's some interesting things in the chat beyond which we've gotten to. Dan Brinkley has a few comments, and I see from also some comments there that Till is going to follow some of the conversations here up next week. So I hope all that people will be able to join and invite your friends. And with that, I want to thank Fabian again for generous
Thank you.
time and very interesting talk, and I want to thank everybody for making it a very productive session.
Thanks.
Thank you, everybody, for having me.
Hope to see you next week.
Thanks, Gary.
Thanks. See you next week.
Thank you.
Thank you. Bye.
Bye. Thanks a lot.